SV Math Teach back one more time for the last video in the series on Pythagorean theorem. Remember to hit that button if you like what you see. Today we're going to work on applying Pythagorean theorem to find distance between points. Now this is a pretty algebraic skill that we're going to be doing. So I'm going to show you two different ways to do this particular skill. We're going to be using the calculator on the right. First, the basic idea here is this. Let's imagine that I wanted to find the distance between point D and point E. Now we wouldn't need the Pythagorean theorem. We would just count, right? We would just do 1, 2, 3, 4, 5, and we would say it's 5. Or what happens if I wanted to find the distance between E and F? I would just count 1, 2, 3, and 4, and I would just say 4. That's super easy. Same idea. What if I wanted to find the distance between D and F? Well, it's a right triangle because it's drawn on a grid, right? So we have that right triangle. This would just be, the distance from D to F would just be the Pythagorean theorem. It would just be an application of the Pythagorean theorem. So let me show you two different ways to do this exact problem, and then we'll follow it up with a new one, and that'll be that. So let's take a look at this technique, right? Here comes a question. It says, find the distance between these 2 points. Now these 2 points were the ones that I had in my original drawing, and let's imagine that there are 2 options. The first option is make a picture. So I love this option, right? It's not the only way to do it, but it's a way. You create or you draw, or if you're on an iPad, you insert a sticky, and you create a coordinate plane. You graph 3, -1. 3, -1's down here. You graph -2, 3. That's up here. You connect the points in blue. That's what that blue line is. And then I used purple to complete the drawing of a right triangle. So the purple lines have to be on the grid. They could be here and here, or they could also be here and here. It wouldn't really make any difference. You count up the side lengths. They're 5 and 4. You solve the problem using Pythagorean theorem, and you get approximately 6.4 units. That's it, right? Very, very simple. If you are a visual person, this is a great strategy for you. But I'll tell you the reason why you need a second strategy is because if your teachers are evil or they just want to challenge you, they won't pick these softball numbers like 2s and 3s and 1s and -1s. They'll pick things that are kind of mean like 25 or 50 or 1,000. And they'll pick things that are very difficult to graph, and therefore they don't want you graphing them. They want you using a different strategy. So what I'm going to do, for fear of making this a little messy, what I'm going to do is I'm going to try to show you a different plan that requires the same kind of thought process, but not a drawing. So watch this. Option number 2 is what I'm going to try to show off in this video. The first step in option number 2 is, instead of drawing anything, calculate the distance between your x values. Now your x values are 3 and -2. That's the 3 and the the 3 and the -2. We're trying to figure out, why am I doing that wrong? It's the 3. See, even I get it wrong sometimes. It's the 3 in the x and the -2 in the other x. How far apart are those things? Well, to figure out how far apart they are, you can subtract them. Now, there's some absolute value work here, but I'm just going to go ahead and show you that it's 5, because I think you can follow that the difference between 3 and -2 is 5 spaces. Now, I messed up the first one enough times. I'm scared to mess up the second one. Let's calculate the distance between the y values. Between -1, which is here, and 3, which is here, the difference between them is 4 spaces. Right here it is. The difference between them is 4 spaces. And then use the 5 and the 4, from the 5 and the 4. Use the 5 and the 4 to solve Pythagorean theorem. Right? The 4 goes in the A spot, the 5 goes in the B spot, and you solve. Now, there's a lot of stuff going on with the drawing there, and I messed it up a little bit, which didn't help. So let's go to one clean example that you can follow with no drawing whatsoever, and watch how easy this is. I do have a calculator, so I'm going to take advantage of that. Step number 1. How far apart are your x's? The difference between 4 and 2 is 2. Now, how far apart are your y's? the difference between -3 and 10 is 13. We're going to use this 2 and the 13 as your A and your B. What am I trying to find? I'm trying to find the C. So here we go. A squared plus B squared equals C squared. Pythagorean theorem. 2 squared equals 4. 13 squared is 169. And C squared is our unknown. 169 plus 4 is 173. Is C squared. Square root to both sides. And we're done. 13.15 is the approximate value for C. Now, I hope you see how easy this technique is. Color-coded so you can see we find the difference between the x's, the difference between the y's, and those two numbers, in this example, 2 and 13, are your A and B. Good luck finding the distance between points, whether you go with the graph version or you go with the one that's on the screen right now, the formula.